Okay, so we have this question here under circular motion. It says determine the centripetal force on a mass of 1.5 kg whirled in a circle of radius 6 meter at a steady rate of 2 revolutions per second. So, first of all, we know that our force, let me write down the solution. Our force, our centripetal force, is equal to mv squared over r, where the m stands for our mass, the v stands for the linear or tangential velocity, the r stands for the radius. So, but for the mass, we know our mass is according to the question, 1.5 kg. So 1.5 kg is our mass, and our radius is 6 meters. That's the r in the equation. So the radius is 6 meters. So the question is, what is our velocity? Because it's moving at this rate. This value is not the linear velocity or the tangential velocity that we have in this formula here. So what we can do is, we know that from this information we have here, that we have our v being equal to the angular velocity times the radius. So since we know that our v equals to angular velocity times the radius, the next question will be, what is the angular velocity? That's the next question. So we can have it this way. The angular velocity is also equal to the angle in radians covered by that particular mass while moving in that horizontal circle divided by the time. So, and this angle must be in radians, and we know that 360 degrees equals to 2 pi in radians. So if you want to convert 360 degrees to radian, you will have it as 2 pi. And of course, when you have 360 degrees in this form, we know that that is equal to 1 revolution. So we can equally write that 1 revolution representing 360 degrees is also equal to 2 pi. So I'm trying to get the angle in radian. I'll fix here so that I can get my angular velocity, and once I get the angular velocity, I can finally get my tangential or linear velocity. And when I now get the linear velocity, I can fix into this formula and finally get the centripetal force I'm looking for, because now the issue is my v. The v, that's question mark, but this same v is equal to the angular velocity w times the radius. So we're working on the angular velocity now so that we can fix into this formula here. So 1 revolution equals 2 pi, and here we have 2 revolutions. And if you want to interpret this question again, we can have it this way, that if 2 revolutions equals 2 revolutions per second also means 2 revolutions in 1 second. So 2 revolutions in 1 second. So that's what it means. 2 revolutions per second, or actually means 2 revolutions in 1 second. So we are converting this to radian now, to an angle we can fix here to get the angular velocity. So if 1 revolution equals 2 pi, then it means 2 revolutions will be equal to 4 pi. So this is exactly what we need now. So if 2 revolutions equals 4 pi, then we are fixing our 4 pi here as our angle in radian. So I will now say my angular velocity will now be equal to 4 pi divided by, I'm rewriting this now since the 4 pi is going to replace the angle here, and the 4 pi is in radian, is replacing the angle here in radian, then divided by my time. Since it said 2 revolutions in 1 second, my time is 1. 2 revolutions in 1 second, that's my time. So my time is 1 second, which is still the same thing as 4 pi divided by 1 is still 4 pi. So finally I've gotten my angular velocity. So the angular velocity equals 4 pi, and that is to say 4 pi rads per second. Rads per second. So now we can now find our velocity, our v, linear velocity. Linear velocity equals to the angular velocity times the radius. That will now be, our linear velocity will now be equal to 4 pi times the radius, which is 6. So the tangential velocity will now be 24 pi. So we can now fix the v, because we have our m as 1.5, we have our r as 6. The v here, the linear velocity or the tangential velocity, was the main issue here. So finally we have gotten it as 24 pi meters per second. That's a unit for the linear velocity. We can now fix it into the formula for the centripetal force F. So centripetal force F will now be equal to mv squared over r. So the force will now be equal to 1.5 times this v squared, means I'm going to square the 24 pi all squared over 6. So if you punch this into your calculator, you end up having your force. Just punch this value into your calculator. You end up having your force has been approximately 1,421 Newton. So that's it. Very, very simple.